So let's continue with some remaining solved examples from maths chapter circles. And this is the continuation from the video which I posted yesterday. Let's finish this part 1 today. Two circles with center O and O dash intersect at P. Through P, a line L parallel to OO dash meeting the circles at C and D is drawn. Prove that CD is equal to 2 times OO dash. See, the figure is something like this. Okay, so let me draw the figure separately over here so that we don't have any confusion. Okay, so these are our two circles with center O and O dash. This is O, this is O dash. Intersect at P. This point is P. Through P, a line L parallel to OO dash meeting the circles at C and D is drawn. Okay. Through P, a line L parallel to OO dash, so this line is parallel and this line is called line L. Meeting the circles at C and D. Okay, so this is point C, this is point D, this is point P, this is OO dash. Prove that CD is 2 times OO dash. Okay, so let's write given over here. So given is L is parallel to OO dash. And L is parallel to OO dash, or which implies that CD is parallel to OO dash. Okay. To prove CD is equal to 2 times OO dash and construction draw OA perpendicular to CP and O dash B perpendicular to CD. CD, actually we should write CD because it's a straight line. So I will draw a perpendicular over here. This is my construction OA and O dash B. Okay, so that's the construction. Now let's move ahead with the question. Let's write the proof. Now A is the midpoint of CP. Since perpendicular drawn from the center of the circle bisects the chord. Since perpendicular drawn from the center of the circle bisects the chord. Okay, so A is midpoint of CP. Therefore, we can say that AP is half of CP. Number 1. Similarly, B is midpoint of PD. B is midpoint of PD. Same reason. Since perpendicular drawn from the center of the circle bisects the chord. Therefore, we can say that PB is half of PD. Now, if we add 1 and 2, we get, adding 1 and 2, what do we get? We get AP plus PB is equal to half of CP plus half of PD. So AP plus PB is equal to AB. AP plus PB is equal to AB, which is equal to half of CP plus PD. So AB is equal to half of CP plus PD, that is CD. AB is half of CD. Now, if you notice carefully, I would like to show you some more things. If you notice carefully, AB is parallel to OO dash, right? Therefore, angle AOO dash is equal to angle OAB, which is equal to 90 degree, and angle BO dash O is equal to angle ABO dash, which is equal to 90 degree, since they are co-interior angles which are supplementary. Co-interior angles are supplementary. Okay, so this is the reason. Let me show you in the figure what I am talking about. See, AB is parallel to OO dash. That is given in the question. So these two angles are supplementary. These two angles are supplementary. So if this is 90, this has to be 90. So ABO dash O. Therefore, ABO dash O is a rectangle because all angles are 90 degree. And therefore, we can say that AB is equal to OO dash, opposite sides of rectangle, and therefore we can say that OO dash is equal to half of CD. OO dash is equal to half of CD. OO dash is half of CD. That's what we wanted to prove. Or CD is 2 times OO dash. CD is 2 times OO dash. Cool. So this is done. Question number 6. Please note it down carefully. Let's go to question number 7. There are 12 questions in all. Two chords AB and CD of a circle are parallel to a line L. Two chords AB and CD of a circle are parallel and a line L is perpendicular bisector of AB. Prove that L bisects CD. Okay. So this is a circle in which we will draw two chords AB and CD. So this is AB and this is CD. So two chords AB and CD of a circle are parallel and line L is perpendicular bisector of AB. Okay, so we have to draw a line L such that it is the perpendicular bisector of AB. Let's name this point as P, this as O, and this as Q. So we'll write given over here. AB is parallel to CD, L is perpendicular bisector of AB, L is perpendicular bisector of AB. Therefore, P is midpoint of AB. Okay, P is midpoint of AB. Also, angle P is equal to 90 degree. That's what is given to us. Great. So we have to prove that L bisects CD. L bisects CD. Okay, so that's very simple. Now we can understand that in proof we have to write this. In a circle, perpendicular bisector, this is a theorem, okay? Perpendicular bisector of a chord always passes through its center. In a circle, perpendicular bisector of a chord always passes through its center. Therefore, L passes through center O. Line L passes through the center O. That was very easy to prove. Also, angle, we can name this point, let's say S. Angle SPB is equal to angle PQD is equal to 90 degree. Angle SPB is equal to angle PQD is equal to 90 degree. So this is 90 degree, and you can say that they are corresponding angles. Angle SPB is equal to angle PQD is equal to 90 degree, corresponding angles. Therefore, we can say that L is perpendicular to CD, and therefore a line drawn perpendicular from center of circle to a chord bisects it. Right? L is passing through the center, and we know that L is perpendicular to CD because angle P is equal to angle Q, corresponding angles. Right? So perpendicular drawn from the center of a circle to a chord bisects it, and therefore we can say that CQ is equal to QD is equal to half of CD. CQ is equal to QD is equal to half of CD. Right? So therefore we can say that Q is midpoint of CD. Q is midpoint of CD. So therefore we can say that L bisects CD. That is proved. L bisects CD. Okay, so this was easy. Let's go to the next question. Question number 8. If a diameter of a circle bisects each of the two chords of a circle, prove that the chords are parallel. If a diameter of a circle bisects each of the two chords of a circle, prove that the chords are parallel. So this question is exactly opposite, or you can say converse of the question which we just did. Let me draw the diagram which is exactly same as the previous one. If a diameter of the circle bisects each of the two chords. Wait, we have a diameter over here. Okay. So let's draw a diameter from this end to if diameter of a circle bisects each of the two chords of the circle, prove that the chords are parallel. Let me draw two chords. So this is one of the chord. We can say that this is the diameter AB. So this is the chord PQ. This is R. Diameter of a circle bisects each of the two chords. This is the first chord. And we can say that this diameter is bisecting this chord PQ at point R. Let me draw one more chord. This is XY and this is Z. If diameter of a circle bisects each of the two chords of the circle, prove that the chords are parallel. So here we can say that XZ is equal to ZY. Okay, let me write given. AB is the diameter. So of course it passes through the center. PQ and XY are two chords and R and Z are respectively midpoints of PQ and XY respectively, so I have already written. Okay, so therefore we can say that PR is equal to RQ and XZ is equal to ZY. PR is equal to RQ, XZ is equal to ZY. Okay, to prove PQ is parallel to XY. PQ is parallel to XY. Construction is not required because this is like a three-liner proof. Okay, so we can say that OR bisects PQ. Why? Because it's given. OR is a part of diameter AB which bisects PQ. Therefore, we can say that OR is perpendicular to PQ. What is the reason? Line drawn from the center to the midpoint of a chord, bisects it. Line drawn from the center to the midpoint of a chord bisects it. Okay. Hey, sorry. Line drawn from the center of the chord to the line drawn from the center to the midpoint of a chord is perpendicular to it. So OR is perpendicular to PQ, and therefore angle ORQ is equal to 90 degree. Also, we can say that OZ bisects XY. It is given. So therefore we can say that OZ will be perpendicular to XY. What is the reason? Same reason which we gave earlier, this one. Line drawn from the center to the midpoint of a chord is perpendicular to it. Okay, so therefore angle OZX is equal to 90 degree. Now we can say that therefore PQ is parallel to XY, since co-interior angles, that is ORQ and OZX, are supplementary. PQ is parallel to XY since co-interior angles are supplementary. Okay, so we proved that these two angles are 90 degree, and therefore the lines PQ and XY are parallel. So that was little different from the previous question, but yeah, it could be done. So they have drawn a diagram like this. My diagram is little different, but yeah, the method of solving is the same. Next question. Prove that right bisector of a chord of a circle bisects the corresponding minor arc of the circle. Right bisector of a chord of a circle. So we have to make a chord and we have to draw a right bisector. So OR is the right bisector of the chord. Bisects the corresponding minor arc. So minor arc is PS, and we have to prove that PS is equal to SQ. So in given, we will write that OR is perpendicular bisector of PQ. OR is perpendicular bisector of PQ. And we can say that to prove OS bisects P arc PQ. OS bisects arc PQ. Okay, let's see the proof. Here we have to do one small construction. So before proof, there is this construction. We have to join OP and OQ. Join OP and OQ. Now we have to consider triangle OPR and triangle OQR. ठीक है? These two triangles are congruent by RHS test. Triangle OPR is congruent to triangle OQR by RHS test. ठीक है? So these two triangles are congruent by RHS test. If these two triangles are congruent by RHS test, we can say that angle POR is equal to angle QOR CPCTC. That means we have proved these two angles equal. And we know that equal arcs subtend equal angles at the center. Therefore, arc PS is equal to arc QS. Why? Because equal arcs subtend equal angles at the center. Therefore, we can say that OS bisects arc PQ, because if this part of the arc PS is equal to this part of the arc, that means S is the midpoint of arc PQ. So it was very easy to prove by using congruency. I did not write all the steps for congruency. You have to mention everything. Okay, so this is the way you prove question number 9. Let's go to the next question. If two chords of a circle are equally inclined to the diameter through their point of intersection, prove that the chords are equal. This is also easy. Let's draw the figure. There is only single circle. If two chords of a circle are equally inclined to the diameter. Okay, just a moment. Let me perfect. Oh, sorry. There is one small problem over here. Now it is perfect. So they are saying if two chords of a circle are equally inclined to the diameter through their point of intersection. Okay. So the figure can be a little bit different, but this is not wrong. Okay. Let's see. So we have two chords AB and BC, and the diameter is BD. Okay, so they are saying that two chords are equally inclined to the diameter at the point of intersection. That means angle DBA is equal to angle DBC. So in given we can write chords AB and BC are equally inclined to diameter BD. Chords AB and BC are equally inclined to diameter BD. That is, angle ABD is equal to angle CBD. Okay. To prove AB is equal to BC, the chords are equal. Construction. Draw OP perpendicular to AB and OQ perpendicular to BC. OP and OQ perpendicular to AB and BC. Right? Okay. Proof. So we have to prove that AB is equal to BC. That's very easy to prove. Okay. So we'll consider triangle OPB and triangle OQB. OPB and OQB. In triangle OPB and OQB, angle OPB is equal to angle OQB is equal to 90 degree. OPB and OQB both are 90 degree. OB is equal to OB, which is common, and angle OBP is equal to angle OBQ. OBP and OBQ given. Therefore, triangle OPB is congruent to triangle OQB by AAS test. Okay, so since the triangles are congruent now, we can say that therefore OP is equal to OQ. OP is equal to OQ. CPCTC. Okay, and since OP is equal to OQ, we can say that AB is equal to BC. How can we say this directly? Because chords which are equidistant from the center are equal in length. Chords which are equidistant from the center are equal in length. This is one of the theorem. So see, we have proved that OP is equal to OQ. That means these two distances from the center, perpendicular distance of the chord from the center are equal. That means the chords are equal. If the chords are equidistant from the center, then they are equal in length. That means AB is equal to BC. So we can directly prove AB is equal to BC using this method. Right? So this is the construction diagram and everything. Nothing was given in the question, so I made everything. My diagram might be little bit different from the diagram which they have drawn. Let's check. No, that's not so much different, although my diagram is easier to understand, but they have proved in the same way. Question number 11th. AB and CD are two parallel chords. Okay, so this is the diagram. Let me draw it while reading the question. AB and CD are two parallel chords AB and CD are two parallel chords of a circle which are on opposite sides of the center such that AB is 10 centimeter and CD is 24 centimeter. And the distance between AB and CD is 17 centimeter. So the distance between them will definitely be the perpendicular distance. So the distance between them is the perpendicular distance. AB is parallel to CD, OP is perpendicular to AB, and OQ is perpendicular to CD. AB is equal to 10 centimeter and CD is equal to 24 centimeter. And PQ is also given. The distance between them is 17 centimeter. Find the radius of the circle. We have to find the radius. To find radius. Okay, so construction which we will do is join OB and OD. So let the radius be R. Okay, solution. Okay, so therefore we can say that OB is equal to OD is equal to R. Also, perpendicular to a chord always passes through the center. Therefore, PQ passes through center O, right? And we can say that also perpendicular drawn from the center of a circle, perpendicular drawn from the center of a circle to a chord bisects it. Perpendicular drawn from the center of a circle to a chord bisects it. Therefore, we can say that OP bisects AB and OQ bisects CD. OP bisects AB and OQ bisects CD. Therefore, we can say that PB is equal to half of AB, which is equal to half of 10, which is 5 centimeter, and QD is equal to half of CD, which is half of 24, which is 12 centimeter. So let me write over here that this is 5 centimeter and this is 12 centimeter. Okay, so all the you can say background is ready. मैंने पहले क्या किया, मैंने ये प्रूव किया कि OB और OD को ज्वाइन करके कि दोनों इक्वल है बिकॉज दोनों रेडियाई ऑफ द सर्कल है, तो दोनों का R ले लिया. देन आई प्रूव्ड दैट परपेंडिकुलर ड्रॉन to a chord always passes through the center. राइट। तो OP और OQ दोनों परपेंडिकुलर है, तो O सेंटर होगा, POQ स्ट्रेट लाइन होगा। ऑल्सो परपेंडिकुलर ड्रॉन फ्रॉम द सेंटर ऑफ द सर्कल बाइसेक्ट्स द कॉर्ड, सो P मिड पॉइंट होगा, P मस्ट बी द मिड पॉइंट। अच्छा, ये दोनों पैरेलल कॉर्ड्स भी है ऑल्सो, ये दोनों पैरेलल कॉर्ड्स है, तो मतलब अगर ये परपेंडिकुलर है तो ये भी परपेंडिकुलर होगा। और ये तो डेफिनेटली डिस्टेंस बिटवीन बोथ द कॉर्ड्स दिया है, तो डिस्टेंस बिटवीन टू लाइन्स इज ऑलवेज द परपेंडिकुलर डिस्टेंस, राइट। सो दैट ऑल्सो वी कैन प्रूव। ठीक है, यहां तक हो गया है। नाउ लेट्स कम टू, दिस इज अ बिग question, okay, it has a, the solution is big. Now we can say that let OP is equal to x centimeter, therefore PQ is equal to OP plus OQ. So PQ is equal to OP, which is x, plus OQ, which we don't know. PQ is 17 minus x is equal to OQ. So if this is x, this is 17 minus x. Correct? Now we can apply Pythagoras theorem. By Pythagoras theorem, in triangle OPB, OB square is equal to PB square plus OP square. So OB is R square is equal to PB, which is 5 square, plus OP, which is x square. Equation number 1. And in triangle OQD, also by Pythagoras theorem, we can say that OD square is equal to OQ square plus QD square. So OD square is R square, OQ square is 17 minus x the whole square plus QD square is 12 square. That is equation number 2. Now what we can do is, we can, because both the equations are in terms of R square, both are the values of R square, we can equate them. So we can say, therefore from equation 1 and 2, we can say that 5 square plus x square is equal to 17 minus x the whole square plus 12 square. So 25 plus x square is equal to 17 square, which is 289, minus 34x plus x square plus 144. X square gets cancelled. 34x comes this side, and 289 plus 144 minus 25. So 34x is equal to 144 minus 25. Let's first add 289 plus 144. That's 433 minus 25, which is 408. So x is equal to 408 divided by 34, which is 12 centimeter. So x is 12 centimeter. I'll show you what is x. X is over here, which is 12 centimeter. So we can find the radius. But how do we find the radius? Don't do Pythagoras theorem all over again, because we have already got equation number 1. Therefore, r square is equal to 5 square plus x square. X is 12, so 12 square. So r square is equal to 25 plus 144. So r square is equal to 169. So r is equal to under root of 169, which is 13 centimeter. So the radius is 13 centimeter. Okay, so that's how you find the radius. Let's check out how they have written. So they have also joined OAOC and LOM. They have proved collinear. Then they have taken this as x. This is 17 minus x. And the same way they have done Pythagoras theorem and they have found the value of x, and then they have found the value of r the same way. So this is the final question of this part 1. As you can see, the parts are big of this chapter. Prove that the line of the centers of two intersecting circles subtend equal angles at the 2 points of intersection. Okay, let's draw two circles, two intersecting circles. Okay, so these are two intersecting circles. Prove that the line of centers of two intersecting circles. So we'll join their centers. Line of centers. This is the line of centers. Okay. O dash. Subtends equal angles at the 2 points of intersection. So 2 points of intersections are A and B. Subtends equal angles at the 2 points of intersection. This is one of the angle, OAO dash, and this is the other angle, OBO dash. So we have to prove that OAO dash and OBO dash are equal. For that we need to do a construction. We need to join AB. Okay, so let's mention given to prove everything. Circles with centers O and O dash intersect at A and B. To prove angle OAO dash is equal to angle OBO dash, that is the line joining the centers of two intersecting circles, subtends equal angles at the 2 points of intersection. Great. To prove OAO dash is equal to OBO dash. Construction. Join AB. Join AB. Okay. Now the proof. Now proof is not too lengthy over here. In triangle OAB, OA is equal to OB, radii of circle, right? Therefore, angle OAB is equal to angle OBA, angles opposite to equal sides. Okay? So this angle is equal to this angle. So therefore angle OAB is equal to angle OBA is equal to x. तो ये दोनों एंगल कितने हो गए x. Similarly ये दोनों एंगल भी इक्वल होंगे. See, these two radii are equal, so angles opposite to equal angles are equal. In triangle O dash AB, O dash A is equal to O dash B, that is radii of same circle, and therefore we can say that angle O dash AB is equal to angle O dash BA, angles opposite to equal sides. ठीक है. So this side is equal to this side, radii of the circle, and this angle is equal to this angle. So let angle O dash AB is equal to angle O dash BA is equal to y. इन दोनों को हम y ले लेते हैं. ठीक है, इन दोनों को y ले लिया. Therefore angle OA dash is equal to x plus y. Also angle OBO dash is equal to x plus y, as you can see over here. Therefore angle OAO dash is equal to angle OBO dash. Proved. We have proved that the line joining the centers of two intersecting circles subtend equal angles at the point of intersection. That's what we needed to prove. Right? The same thing. So we have successfully completed the first part of this chapter, circles. As you can see, I had to make 2 videos. It's a huge part, but it is completed. So I will see you in the next video. Bye.